Alright, hello everybody. This is like my fourth time recording this because it keeps messing up. So I'm going to go over my gummy bear project with unsalted and salted waters. Excuse me, salted water. So the setup's pretty easy. I used 2 little whiskey glasses, and I'll show you here in a second. 1 pack of organic gummy bears because Publix was out of regular gummy bears. And some tap water, and a lot of salt. I also poured salt on the stove, spilt some, so don't judge me on that, please. And the gummy bears, I dropped roughly 10 in each one. I started the project at, I think, right at 8 o'clock in the morning, and reviewed the results around 6 o'clock that afternoon, so right at 10 hours. Let's see here. Alright, so let me play this first video. This was my setup. You can see I already had the water in it. Up here. So I poured salt there. It's a good bit of salt, and then I went ahead and decided I would spill some on the stove right there. And you can see up here, well, when I put the glass down, you can see up here it's almost 8 o'clock in the morning. We'll go forward a little bit. I have that mixed up, and then go back here so I can show you this pack of gummy bears. So I don't know again if this plays any factor in it, but they're gluten-free, fat-free, low sodium. They're the healthy gummy bears. So there's that. So I placed, like I said, roughly 10 in each, and you can already see the cloudiness versus the clear structure. And yeah, right at 8 o'clock. So that was my first one. And let's see here. Just tabbing through here. So after reading the textbook and researching a little bit on my own, I had a running theory that it was osmosis. It's one of the few processes that, works in pretty much anything you soak up through water or with water. Through the process of osmosis, some of the water molecules move from the water in the jar to the water in the bear, the gummy bear. So it works like the same way you would do a sponge or anything else, like it's a piece of bread. Anything else that has a high solute or a something that's not containing gas and water, that's easier to move through that permeable wall during that reaction. I'm sorry. So yep, they're made of gelatin, the gummy bears, which when they make the gummy bear, I'm sure we all know this, but when they make the gummy bear, they actually pull a crap ton of the moisture out to keep it as a solute instead of a solvent, so that it can be absorbed. Let's see here. Yep, like a sponge, rather than dissolving in the water, the gummy bears grow. The link right here is by the Amoeba Sisters. It's actually, we used this video in tech school when we were going through IVs and the way it works in the blood, the process of osmosis in the body and the blood. So they use this video. It dumbs it down very good, or very, very well for us. The 108 to 342 time span is kind of the best, most accurate pertaining to this project. Let's see here. So again, I took the last video. The last video shows what they look like. It shows what each set of gummy bears coming out of the glass, how they reacted to the salt and lack thereof. So last video, see both sets of gummy bears reacted different to the water they were placed in. The water without salt left the gummy bears engorged, very jelly-like and slippery, while the water with a high concentration of salt left the gummy bears a little bit smaller, kind of shrunk them. Even smaller than the ones that are in the pack. So after seeing this, it confirmed my theory. Concluded it was through osmosis that each set of gummy bears were altered. For each glass of water, with and without salt, gummy bears are hypertonic, meaning they have a higher solute concentration. So solvents absorb into the solute. Therefore, the water fills the spaces in the gummy bears to make the net movement equilibrium equal 0. In other words, that entire surface area the water's in, you take something, you drop it in it. Now there's something there that does not have the same amount of water molecules. The equilibrium is off. So that water is absorbed into the gummy bear or whatever you put in the water until that equilibrium equals back out to 0. Let's see here. So to sum it up, water without salt was absorbed into the gummy bears, causing them to swell due to the high solute concentration in the gummy bears. The water molecules moved to that. The water with a high salt concentration, the salt water, pulled what little moisture the gummy bears already had out, which gave them this kind of like white, salty look on the outside almost, resulting in them shrinking due to the high solute concentration outside of the gummy bears. So because the gummy bears, they are a solute, they have a high solute concentration because there's not a lot of moisture in them, but there was so much salt outside of the gummy bears that it pulled, what was in the gummy bear out. Both reactions due to the process of osmosis. I will show that last video real quick, and this is the result. Again, I don't know what's going on with the video. It's not showing any sound. You can see too, they swelled. You can see like this clear film around the gummy bears through the glass, where there's so much water in them, and they're swollen. And then the regular, I'll show here in a second with them. This is the salt water, and you can kind of see like this white film right there all around them. I think I pulled the colored one out. It shows it a little bit better. Yeah, a little bit better. Yeah, there we go. Okay. So I'll compare them here, I do believe. So I picked yellow. So you can see the size difference. This is the water with no salt, with salt. And I mean, it's barely smaller than the original, but the fact that it didn't engorge near as much shows that all of this salt kind of pulled what moisture was in the gummy bear out. And yeah, I mean, that's it. These are just the links. This is where I got most of my information, and the textbook as well, and then the Amoeba Sisters video is on here if the link right here does not work for some reason. Alright, and I just wanted to show this really quick. When you go to it, this minute 10-second area talks about the water molecules traveling from high concentration to low concentration. It tells you what a solvent versus solute is, the membrane. It's very colorful and creative. It works wonders. So teaches you the difference of hypertonic and hypotonic, which are both in the book. Alright, so watch that. It'll give you a good indication. And thanks for watching. I really appreciate it.